Ever wondered how a prediction about the future price of a stock or the likely sales of a product is made? The answer lies in a statistical procedure called regression analysis. Strap in as we embark on a journey to unravel the mysteries of this powerful tool. Regression analysis is a supervised learning technique used to predict a continuous outcome or a dependent variable based on one or more input features, often known as independent variables or predictors. It models the relationship between the input features and the target variable, and this relationship is represented by a mathematical equation that estimates the target variable based on the input features. In the vast realm of regression, there are several types, each tailored for different scenarios. The choice of regression type depends on the nature of the data and the problem at hand. Linear regression, for instance, is one of the simplest and most widely used regression techniques. It assumes a linear relationship between the input features and the target variable. Here, the predicted variable is calculated as the sum of the intercept, the product of the coefficient and the input feature, and an error term. For multiple linear regression with more than one feature, the equation simply extends to include each feature and its associated coefficient. Then we have polynomial regression, which extends linear regression by allowing for polynomial relationships between the features and the target variable. This is especially useful when the data exhibits a nonlinear pattern that cannot be captured by a straight line. Ridge and lasso regression, on the other hand, are regularization techniques used to prevent overfitting in linear regression models. They introduce penalty terms to the linear regression equation, encouraging smaller coefficient values. Ridge regression adds the sum of squared coefficients to the error term, while lasso regression adds the sum of absolute values of coefficients. Then there's logistic regression, used when the target variable is binary. Despite its name, it's actually a classification algorithm, modeling the probability of the target variable belonging to a particular class. To summarize, regression analysis is a powerful technique used for predicting a continuous outcome based on one or more input features. Linear regression, polynomial regression, ridge and lasso regression, and logistic regression are some of the common types used, each suited to different scenarios and data types. Remember, the magic of regression analysis is not just in understanding the mathematics behind it, but in how we apply it to solve real-world problems. So, keep exploring, keep learning, and let the power of regression analysis guide your predictions.